Good morning and welcome to TEMO, our fifth lecture. We will start with the introduction to theory as we did the previous week, and then we will move on to the talk show and then the wrap-up. So now we can see our iceberg again. We have finally reached almost the bottom of the iceberg since we are now talking about the STAR model and about the internal organizational issues that lay behind technology. So the agenda for today will be, as usual, an introduction on implementing a business model with a connection from the theory to a case of the challenger that I mentioned during the introduction on our first day. Then we'll have a break. Then we have a great talk show with Morten Schulz from GN Store Nord, who will tell us their approach to the STAR model and specifically concerning people and rewards. And finally, after a last break, we'll have a wrap-up where we will connect the theory with what was talked about during the talk show. So without further ado, let's start with the theoretical introduction on implementing a business model. Last week, you were introduced to the STAR model, which concerns the different element of organizational designs that lay behind organizations. In the STAR model is consisting of 5 main elements that are strategy, structures, processes, reward system, and people practices. And all these 5 elements need to be aligned. They need to fit with each other for the organization to work properly. And this is what the concept behind the STAR model is. If you can connect the STAR model to one of these baby toys that are very popular in Denmark in your mind, and maybe you can understand how it works. So this toy is a connection of little balls and sticks through elastics. I don't know if you've seen it, but it's very popular here in Denmark. You usually give it to babies because it's very easy to grasp. And when the baby pulls it, the toy goes from having some sort of round shape into going into a longer shape. And it's the same with the STAR model. If you change one of the 5 elements of the STAR model, for example, processes, then the STAR will be pulled towards this corner. So some of the lines connecting the elements will become longer. And that is a signal that the organizational design is not perfectly aligned. And that could originate a lot of different problems. So what you have to do is try to adapt the other element of the STAR model so that the STAR goes back to its original shape, just as the toy does when you stop pulling. Today, what we will do is we will go through the STAR model again by analyzing the case of NASA and the specific case of the Challenger, which was a shuttle that was launched in the 80s. So to start that, I just would like to ask how many of you have seen this picture in the last couple of weeks? A couple of you? Well, this is an ideal image of a planet that's called TRAPPIST-1F, and it's one of the 7 planets that were just discovered by NASA just a couple of weeks ago. This was is one of the missions on which NASA is working on at the moment. By using telescopes, they're actually exploring the space on a constant rate. And what they found out was that there is 7 small planets that are actually very similar to the Earth and that could even be habitable and that rotate around a specific star. And this is one of them. Another mission of NASA is the rover on Mars. And these are actually 2 pictures that were taken from the rover that represent the sand below the rover while the rover is not moving. And one of the missions that is also very famous is the International Space Station. This is a picture of how the International Space Station is composed, so the different technical elements that all together compose the International Space Station. And then, of course, what is missing is the shuttle that goes back and forth from Earth and that connects the International Space Station to us. The International Space Station was launched in 2000, but its project is actually much older. It was actually originated in the 70s by Nixon. that approved a plan by NASA to keep on having an active space program by working on the construction and launch of the International Space Station and of the shuttle that will connect them to Earth. So what we will do today, we will go back in time into the shuttle program of the 70s, and we will analyze what happened in the case of the Challenger by using the STAR model. What we would like to do through this exercise is to show you a way to use the STAR model to analyze the case, just the same as you have to do with your cases in the afternoon and just the same as you have to do in the real-life challenge. That will be the second part of the course. So the shuttle program was started in the 70s, as I mentioned, by Nixon. And if we look into the STAR model, the strategy of the shuttle program was to maintain an active space program while keeping it modest. When NASA went to Nixon at the end of the 60s, they had three plans in mind. They could launch the Apollo, which was a very expensive project. They could do a middle-range project, or they could go for the cheapest option, which was the International Space Station and the shuttle program to connect it to Earth. Nixon didn't want to keep the high-level expenditure because at that point in time he didn't feel like space was something as relevant as the other issues he was dealing with. So this originated a cost reduction strategy in NASA, which was based on the idea, yes, we want to be in space, yes, we want to be active, but we don't want to spend too much money doing so. So they decided that they were going to work on launching an Earth orbiting space station with the shuttles that will connect the station to Earth. At the time, the structure of NASA was very flat. It was very tall. You have seen last week, you can have tall organization, very hierarchical, and you can have very informal, flat organization. In the 70s, just as many other governmental organizations and institutions, NASA had a very hierarchical structure. Moreover, it was divided in different center fields that are similar to what the book refers to as divisions. And each field was responsible for different projects. When they launched the shuttle program, they decided to divide the space shuttle responsibility across three different field centers that were located in different facilities across the United States. On top of that, they decided to hire an external contractor for the different components of the shuttle, as they were used of doing, and they launched a tender to do so. Remember that the strategy was to maintain a modest space program. So the same was applied to the tender that they launched to hire the external contractor, which resulted in hiring for some of the part contractors that did not have experience with that type of products or technology. And an example of this is the O-rings, which were a sealing ring that absorbed the power and the movements from the motor of the shuttle itself, and made sure that the shuttle didn't explode. And the producer of these O-rings did not have experience with that technology before, but it was the cheapest one in the tender. So it was higher and was one of the external contractors that were put into the structure for the shuttle program. When we look into the processes of NASA, especially in the 70s, we can see that what they were working with was reciprocal performance task, meaning that all the different parties that were working on the components of the shuttle and on different parts of the project, they were all working towards a common final goal, which was the shuttle itself. And without coherence, without a good communication, without a good management of the different parties that were working on the components, it would be very difficult to achieve the final task to build the shuttle, because all the tasks were dependent on each other. But we will go back to this later on. On top of this, the processes were mostly based on feedback control and output control, meaning that NASA was mainly working with the idea that first you produce a prototype and test it, and then you go back. So a very technological-based approach also to management processes that made so that everything was first tested and then eventually changed afterwards. Looking into the reward system, rewards at NASA worked the same as they worked in many other institutions at the time. And they can be classified through the different theories that you find in the book on the reward system. But we will go back to this later. And finally, in terms of people practices, one characteristic of NASA was that they collected a variety of different engineers, a variety of different managers with different skills, different background, different characteristics, and they put them together to cooperate on the different projects that they had. Again, if you remember the structure, very tall structure, so all these different type of people were connected into a strong hierarchy where there was a very strong differentiation between roles and power, meaning that your manager was actually your boss, and it was very difficult to change his mind about important decisions. So there was a very strong power and control structure between employees and their managers. When the shuttle program was launched, first there were a series of good results and of successes. At the same time, there was also a major problem, and that was the case of the Challenger. Now I'm going to show you the video of the launch, of the 11th launch of the Challenger, and then we can talk about it later. But please remember that this is a worst case scenario of what can happen when you take bad management decision. It's not something that is very likely to happen to any of you in your future career, but it's to give an idea how bad can it be to actually take a bad management decision, which kind of impact can it have, even on technology like in this case. So, what happened here was a major technical failure, as you can imagine. The Challenger was the second orbiter, so it was not the first one, but at the same time, it was the first, it was responsible for a lot of firsts. For example, it was the first one to use external tanks, and those that were the ones that carried the O-rings that resulted in the technical failure. It was the first that it took to the first spacewalk from a shuttle, and it took Sally Ride to her first trip to space, her being the first woman in space. The NASA shuttle space program was actually successful until this point. The Challenger, had 10 successful launches before this. But what happened here was a technical failure due to a lot of management issues. And that's what we will work with by analyzing the star model. Technically, what happened was that the external tanks that were attached to the shuttle, they had O-rings. The shuttle had external tanks, and to absorb the movements from the external tanks, it actually had these O-rings that were working as seals, and they were supposed to absorb the pressure. The O-rings had been tested up to a temperature of 4 degrees, and up to that moment, all the launches took place as this one in Florida, where the temperature was actually quite good. So there had been no problem due to low temperature. This morning, the temperature was much lower. It had been frosty during the night. And in the morning, the engineers behind the O-rings pointed out to the management, we cannot launch today, the temperatures are too low, we haven't tested for this, there is a high probability that there will be problems with the O-rings. The management at the same time asked the engineers to, they asked, but have you tested it? Do you have proof that it won't work? And they said no, but we haven't tested at such low temperature, so we are quite confident that there will be problems if we launch today. We need to postpone the launch. After a series of discussion and back and forth between the contractors and NASA and the different managers within the organization, the decision was to launch the shuttle anyway. And this was the result. The O-ring broke because of the low temperature, and the shuttle exploded, resulting in the death of the 7 astronauts. And consider that at the time at which this video was taken, so at the time of the launch and of the explosion, the astronauts were actually still alive. So they actually had to wait several minutes until they hit the ocean to die, and that's what resulted in NASA installing ejection seats in the following shuttles. So, if we look into the STAR model, which problems can we identify? First of all, let's consider the strategy. The strategy was we want to maintain an active space program while keeping the costs down. So the cost-saving strategy actually had an impact on all the other elements of the STAR model. And first of all, on the contractor, they choose a contractor that did not have previous experience with this technology. At the same time, the cost-saving strategy pushed them towards taking a fast decision to launch on a morning where the engineers were warning them, please do not launch today. It's a dangerous day, the temperatures are too low, there could be technical problems. But because the launch had already been postponed because of the low temperature and money were being wasted, then the managers were pushing to actually launch as soon as possible. Everything was ready for launch. The astronauts were sitting in the shuttle. Managers really wanted to move forward and had the shuttle launched. The second problem that we can identify based on the STAR model is if we look at the structure. Now, the very hierarchical, the very tall structure that NASA had, such as the first one, as you saw last week in the theory, brought a specific set of dynamics between the management and engineers that actually had realized that there could be technical problems due to the low temperature. What happened at the moment where the engineers pointed out we cannot launch today was that someone from NASA asked them, from the management of NASA, asked the engineers at the contractor, do you have proof that this is not going to work? And they said, no, we don't have proof, but we have never tested it, so we don't know what's going to happen. We think it's going to be a problem. And then at that point, the management asked these engineers, you need to take, or they asked the contractors, you need to take off your engineering hat, you need to put on your management hat. We want a management decision. Should we launch or should we not launch? At this point in time, the hierarchical structure made sure that the management above the engineers in the contractor took the responsibility, because the engineers said, you know what, we told you this is not a good day to launch, so we don't want the responsibility on this. And the management took the decision. They wrote a handwritten note that you can still find in the description of the case, where they said, we're taking the responsibility and we are saying that it is okay to, in fact, launch the shuttle today. Had the structure not been this hierarchical, it could have been easier for the engineers to actually explain their reasonings and change the mind of their manager. The third type of problem is related to the processes. So let's see how the processes were working at NASA at the time, and let's see how this caused problems. You looked last week at the different types of work processes, and you looked at the different types of task interdependency. You can have a pooled performance when you have different individuals or different people within the team that are working with something, contributing to the final product, but the contributions are separate and independent. And it means that the overall group performance is a sum of what the individual members are working with. Then you can have a sequential performance, which is when the tasks come one after the other, and each person is dependent on the person before them, and so for the task. And then you have reciprocal performance, where the work performed by each of the members is actually fully dependent on the work performed by the others. And at NASA, in the shuttle program specifically, you had different teams working on different components, on different aspects of the shuttle program, but they were working in a reciprocal performance type of task, because every single task was actually fully dependent on the other to work. If you compare this to your own project, to your own group works. In your group work, we are also talking about group performance, because we are not looking at each single part separately, but we're looking at the overall group work. So even if you work on different tasks separately, what we look at is the final result, so you're actually all dependent on each other. If we were instead looking at the individual tasks, so at the individual sections, not looking at the overall report as a single product, then you will have a pool performance where you wouldn't be dependent on the others. If your part was very good and all the other parts were bad, you will still get a good grade. But that doesn't happen because we have a reciprocal performance model also in your group work. A sequential performance would happen if you had a task where the first person is making a design, then you have a second person designing the prototype, and so on. So every person is actually dependent on the person before them. In the NASA case, as mentioned, they were working on the reciprocal performance task, but they did not have the communication, the support, the structure to support this reciprocal performance. So they were actually working separately on tasks where they should have worked all together. So they were working in a pooled way for a reciprocal performance task, and that is what caused problem. Is one of the things that caused the problems. Another thing related to the processes is the types of controls that can be exercised by a manager over his employees. And as is a tradition in engineering, due to the way technology works, a lot of importance in NASA was given on the output stage, and on the feedback control, meaning that first you had to produce something, prototype, test it, and once you had tested the final product, then you could say, okay, it works, it doesn't work, we're going to change it. So you only acted upon the last type of control. Similarly, when we look at the type of control system that work within an organization, a lot of focus in NASA was given on the output control and on the behavior control by having financial measure, performance measures, by having direct supervisions by the managers. But there was also a lot of clan control, and the clan control was actually reflected was actually mirroring the structure that was based on a very hierarchical structure and on a very strong division between roles and power. So there were power dynamics that exercised a lot of clan control that took the management decision making to the point where the wrong decision was taken. If we look into the reward system and the people practice, we can't really find any direct link between the rewards and the problems that they had at NASA. You saw last week a lot of different theories that discuss how people are motivated within organization. I'm just going to go through a couple of them, and then we can just reflect how would this apply at NASA. So first, you have the motivation equation that says that the motivation of employees needs to be aligned with the organizational goals for the performance to be high. So if you have employees that are motivated by what your organization is doing. For instance, you saw Novo Nordisk last week. The vision of Novo Nordisk, the goal and the mission of Novo Nordisk is to say the word by curing diabetes. And they need to have people in their organization that are passionate about that for the performance to be high. Similarly, in my case, if my motivation to research and to teach wouldn't be high, then my performance wouldn't be high either. Because I wouldn't work as efficient as I could, I wouldn't work as effective as I could. So one way to ensure that the performance of your employee is high is to work on their motivation and make sure that their motivation is aligned with the goals of your organization. And on top of that, you can add outcomes that you give to your employees as a result of the performance, such as the pay, the job security, the benefits, job satisfaction, autonomy, and so on. Another model that discusses motivation is the job characteristics model, where you have 5 different job characteristics that you can work with when you're designing a job and you're designing a task for your employee to make sure that their psychological status is actually positive and they're happy at work, because that results in high motivation, which in turn results in high performance and high satisfaction from the work. So you have these 3 critical steps, and by, for example, increasing or by matching the skill variety, the task identity, and the task significance to the right person, you can increase the feeling that the work that they're doing is being meaningful. For instance, if I was not familiar with the STAR model and I was teaching it to you today, I wouldn't feel like my work is meaningful, because my competences, my skills do not match the competences and skill requested by the task, which is teaching you the STAR model. But since I know it, then I feel like it's meaningful. I'm teaching you something that I'm very familiar with, and therefore my performance is higher. Similarly, if you increase the level of autonomy and you match the autonomy to the task and to the person, then you feel like you have more responsibility for the work outcomes and you perform better. And finally, by giving the right type of feedback to your employees, you can actually improve the performance by making sure that they know that what they do is being recognized and other people will see it as well, and that they can improve based on what feedback they receive. In the case of NASA, they probably were working and still are working with people, if we go back to the motivation equation, who have the same or whose motivation matches the organizational goals. So they're working with people that are very performative, and they that actually work well and achieve very good results. And they were quite good in matching the skill variety, task identity, and task significance with the people that they were assigning to jobs, but they were not so good in terms of giving them autonomy and feedback. And we can see that in the type of relationship that there was between the engineers and the managers. And this is reflected also in the people practice. When we talk about people practice, we talk about all the techniques that are used to ensure that the organization can attract, retain, and effectively use human resources. If you look at what happened in the case of the Challenger, for the engineers who were trying to raise their voice and make sure that the launch wouldn't happen on that day because of the risk of technical issues, the fact that their reasons were not listened to could lead to them leaving the company, and therefore it's not a good sign of human resource management. When you talk about human resource management, however, you're also talking about the recruitment and selection. So how do you hire people? You're talking about training and development. How do you train them? How do you make sure they grow and develop and become better and better every day? You're talking about performance appraisal and feedback. How do you tell them how good they are, or how good they have performed, and how bad they have performed, and how they can improve? How much do you provide to them in terms of financial or tangible benefits? And then what are the type of relationships that you have with the unions and so on? Within human resources management system, or within people practices, we also find a group development. So the way that you deal with your group, or the way you group people together, and the way you manage groups. So you've seen last week this model that shows the different steps that a group goes through when it's developing. So from starting the group until the moment in which the group is actually dispersed. And you've probably experienced many of these issues and experienced different of these phases already in your group work, and the same happened to NASA. One of the things that led to the Challenger disaster was that if we look at the way the team worked, and the way the issues arose over the last decision-making processes before the launch of the Challenger, we can see that although the group at that point should have almost been at the adjourning part, it was actually performing, and they were actually about to finish the project once the shuttle was launched. They were still dealing with issues related to the storming phase, because they were still dealing with conflicts and negotiations. They lacked consensus and team spirit, and they hadn't found a balance to work together. So they were actually supposed to be in this stage, but they were dealing still with the forming and the storming issues. They were still trying to decide what are our goals. The engineers wanted the shuttle to not explode, and of course the managers wanted the same, but they had different ideas in mind. The managers had to keep in mind our strategy is to save cost, and we need to launch today. While the engineers had in mind we need to make sure that the shuttle works and that the astronauts can actually go in space without incurring in any technical problems. So there was a misalignment there, and that eventually led to the wrong decision-making and to the disaster. One thing that you might have experienced in your group work, and that might have happened at NASA too, although we don't know about that, especially for this case, is social loafing. And social loafing is when you have a group member that is not contributing to the group as much as it should. So there are 3 things that you can do to reduce group loafing, and they are first, making the individual contribution as identifiable as possible. And that's, for example, what we do with the report when we ask you to specify who wrote what. Then you can emphasize the valuable contributions of the individual members. So every time someone does something really good, you recognize, say, oh, well done, I'm so happy you did it. Or if you have something that worked particularly well, you say, okay, you know what, because you did so well today, we're all going to go out tonight and all buy you a drink. And finally, the last point is to keep in the size appropriate. So if you don't match the number of people in a team with tasks that they need to perform, then there could be a lot of issues. If you assign 6 people to a very small task where 2 people would be enough, then of course there will be a lot of conflicts. Vice versa, if you assign 2 people to a task that require a higher number of people, they will become very stressed and other types of issues would arise, and this might cause social loafing. If you can match these 3 components and make sure that you're finding the right degree of each, then you can reduce social loafing. And one more thing that has to do with dealing with people practices, is leadership. And leadership is the process by which a person exerts influence over another and inspires, motivates, directs the activity of the people to achieve the common goal that the organization has, that the group has. So in your book, you have different models describing leadership. And when we talk about leadership, you need to remember that the leader is different than a manager. A manager can be a very bad leader, and at the same time, a very good leader does not need to be a manager. We can see this in, for example, when you look into the software industry, you have these agile innovation models where softwares are developed at a very fast pace. And within this model, instead of having a formal manager, you actually work with leaders that are called Scrum Master, and they are responsible to keep the process going and to make people work together. But they're not formal managers. They need to have the capability to lead and motivate their group members. In the past, there has been a lot of research, especially in the United States, to identify what are the traits that make a leader successful, what are the traits that make a good leader. So a lot of good leaders were studied, and a lot of lists of leader traits were pointed out until the point where they found out that, oh, surprise, surprise, this list don't work because leadership is dependent on the context. So you can have a very good leader in one situation that is a very bad leader in another one. So other models arose, such as the contingency model that says that you can have either relationship-oriented or task-oriented leaders. So in which situation would one person be more effective than the other? You have the path goal theory that studies how effective are leaders in motivating their followers. And where the good quality of leadership depends on the nature and work of the subordinates. So you have to match the type of work with the person that would be able to lead that type of work. And then finally, you have leader substitutes model that depends where the leadership where it is studied when leadership is unnecessary. And again, you look at the characteristics of the employees and you look at the characteristics of the situation to evaluate that. In another situation, in the challenger situation, a good leader would have supported its engineers and would have empowered them and would have listened to their reasons and allowed them to keep the engineering hat while also taking a management decision and say, no, we're not launching today, it's dangerous, we haven't tested, we cannot guarantee the safety of the astronauts. A last model related to people practice that I would like to show you today is the SHINE model of organizational culture. And I would like to underline that if you decide to use this in your report, you should be really, really careful because it's quite hard to use. And the reason why is that this model actually says that when you look into an organization, you have a certain set of artifacts, you have a certain set of things that allow you to see what the culture of that organization is. And that is given by the organizational structure and processes, for example, or it's given by the visual of the organization itself, or how the building is organized, and so on. So in the case of NASA, you would see that the organization is very hierarchical by seeing that the offices, that every person had their own offices, and the managers had the nicer offices, and the managers of the managers actually had the corner offices. But behind that, lie the values which are defined by the strategies, the goals, and the philosophy of the organization. And this is somewhat easier to identify because it's something that is also quite explicit, or that is made explicit by the organization itself. But this is actually based on some underlying assumption, and the underlying assumptions are not tangible, they're not explicit, and it's very difficult for people to actually express them because they are based on unconscious beliefs. For example, in the NASA case, in the 70s, the unconscious belief that your manager is your manager and he's your boss and is finally going to take the decision anyway. So you can just say, well, I'm telling you this is the wrong decision to take for technical reasons, but I don't want to have any responsibility. I'm stepping out of this and you will take the responsibility for your decisions. So this model tells us there are unconscious underlying beliefs, perceptions, thoughts, and feelings that build up on each other and eventually form the value, the strategy, the goals of the company, which then result in visual artifacts and the things that you can see about an organization. But they're all based, everything that is visual, everything that is explicit and that you can see is based on basic underlying assumptions that are unconscious. So they are not easy to be expressed. So if you decide to work with this model, remember that finding out about this part is actually extremely difficult because people cannot tell you about it, they're not able to. So what we have done today was going through the different elements of the STAR model to analyze a specific case, which was the case of the Challenger disaster by NASA And it is just an example on how you can use the different models to link them to the STAR model and actually analyze the problems that are related to a case. So it doesn't mean that the models only belong to the sections of the STAR model that I showed you today, but it's my way of linking the models, the theories to the STAR model to analyze the Challenger case specifically. So you can actually mix and match the model to different parts of the STAR model, but also the business model canvas, the value proposition canvas, and the other models that we looked at in the rest of the course. So with this, I would like to underline one more time that the STAR model is about the 5 elements of organizational design that needs to be aligned for an organization to work, and they are the strategy, the structure, the processes, the reward system, and the people practices. And when you change one of these elements, then you need to adjust the others, so to make sure that the organization is aligned and well functioning, and all the different elements are balanced. In the second part of today's lecture, we will have the talk show with Morten Schultz from GN Store Nord, who will especially tackle reward system and people strategy as and people practices as connected to the strategy of GN Store Nord. And finally, in the wrap-up, we will connect the talk show to the theory we discussed this morning. With this, I would like to thank you for today, and goodbye.